Science, a systematized study of knowledge. Branches of science we have already discussed in the previous classes: life science, physical science, earth science, etc. In the physical science, the science is concerned with the study of inanimate natural objects including physics, chemistry, astronomy and related subjects, often contrasted with life sciences. Chemistry is a branch of science which deals with the study of composition, structure, properties and change of matter. It is the scientific discipline involved with elements and compounds composed of atoms, molecules and ions. Their composition, structure, properties, behavior and the changes they undergo during the reaction with other substances. In the scope of its subject, chemistry occupies an intermediate position between physics and biology. It is sometimes called central science because it provides a foundation for understanding both basic and applied scientific disciplines at a fundamental level. A colorful spectrum view of the chemistry in the laboratory, particularly analytical chemistry. We have a wonderful color complexities in the analytical chemistry in the laboratory. Chemistry, branch of science which deals with the study of atoms, molecules and ions, as I told you. It's all the atoms are oxygen, hydrogen and nitrogen. This is the structure of the molecules of nitric oxide, water, nitrogen dioxide or nitrogen peroxide, the reddish brown fumes, and carbon dioxide, the structures. Behavior changes they undergo during the chemical reaction with other substances are as follows: the color, composition, structure, physical properties and chemical properties. Elements and compounds contains only one kind of atom is an element, and contains two or more kinds of atoms, they are called compounds. Here, for example, helium, made up of only one kind of atom, helium, and the oxygen is a diatomic element made up of two atoms of oxygen atoms. Same kind of atoms, that is an element. This is a compound. Water is made up of two kind of atoms. One is two hydrogen and one oxygen atom. Water is a compound. It is a universal solvent, my dear friends. Water acts as a predominant role in chemistry. Well, introduction to inorganic chemistry. It is the reaction, synthesis, structures and properties of compounds of the elements. Is usually taught after students are introduced knowing the organic compounds. Organic compounds in only carbon and hydrogen, but rest of the elements in the periodic table is all belong to the category of inorganic chemistry. And the chemical compounds, noble gases, 32 of the chemical elements occur on the earth. In native uncombined forms, most of these occur as mixtures. So this is atmospheric air, nitrogen, oxygen, argon, and native solid elements occur in alloys, such as that of iron and nickel. Classification of elements. Classification elements in the periodic table, particularly modern periodic table. This was especially Mendeleev's periodic table, periods and groups. Elements in the long form of periodic table have been divided into 4 blocks: S, P, D and F blocks. The elements are classified into 4 blocks, that is S block, P block, D block and F block, based on the orbital into which the differentiating electron enters, depending upon the nature of the electronic configuration of each element. This division is based upon the name of the orbitals which receive the last electron. Elements in which the last electron enters the s orbital of the respective outermost shells are called s block elements. These are the s block elements, my dear friends: lithium, beryllium, sodium, magnesium, potassium, calcium belongs to s block elements, that is 4s orbital filling. Include hydrogen, helium, lithium, potassium, calcium, rubidium, strontium, etc. periodic table shows exactly where these elements are within the S block elements. This is the P block elements, my dear friends, and this is the D block elements. These are also called as transition elements. These P block elements found on the right side of the periodic table. S block elements are found at the left of the periodic table. Right of the periodic table, P block elements. In between these S and P blocks, there will be a transition periods, that is D block elements. The noble gases have full p orbitals and are non-reactive. The terms transition metal or element and D block element are sometimes used as if they are the same thing. They do not. There is a subtle difference between the two terms. We will explore D block elements now. You will remember that when you are building the periodic table and working out where to put the electrons using the Aufbau principle, something odd happens after argon. At argon, 3s and 3p levels are full, but rather than fill up of the 3d orbitals, next the 4s level fills instead to give potassium and then calcium. Only after that do the 3d level fills. The element in the periodic table which corresponds to the D levels filling are called D block elements. The first row of these shown in the shortened form of periodic table, that is from 21 to 30, scandium to zinc. This is the modern periodic table, where you can see the non-metals, alkali metals, transition metals, alkali earth metals, rare earth metals, other metals, halogens, inert elements. These are inert gases. These are metallides: boron, silicon, arsenic, tellurium, and actinium. This is alkali metals: lithium, sodium, potassium, rubidium, cesium. And these are alkali earth metals: beryllium, magnesium, calcium, strontium, barium, and radium. So these are the important information about the periodic table and the classification of the elements, my dear friends.